Hello again. In this video, we're going to go over an example where we find the left, right, and midpoint Riemann sums for a function. Okay, so the function we're going to find the Riemann sums for is f of x is equal to 3 times the square root of x. We're going to start at x equals 4 and end at x equals 16. Okay, so let's find the left Riemann sum first with 6 subintervals. So we're going to take this interval from 4 to 16 and break it up into 6 subintervals, each subinterval having the same length. Okay, the length of each subinterval is going to be delta x, which is b minus a divided by n. So in this case, b is 16 and a is 4. So the length of our interval is 16 minus 4 is 12, and then we're dividing that up into 6 subintervals. And so that means each subinterval would have to have a width of 2. And then if you want, you can write down the grid points. We're starting at 4, and we're just moving up by 2. And so these would be the grid points. And then you can see that you do eventually get to 16, which is equal to b, right where we stop. Okay, so those are the grid points. Now, since we're doing a left Riemann sum, okay, here are our grid points, right? So here's our first subinterval from 4 to 6. Since we're doing a left Riemann sum, we're going to pick the left endpoint, which happens to be 4 here in this first subinterval. And we're going to use that to determine the height of the rectangle. So if you plug 4 into the function, you get 3 times the square root of 4. And so that's the height of this rectangle. And then we multiply by the width of the rectangle, which is 2, to get the area of this rectangle. Okay, so this is the area of the first rectangle. And then we just do this for each rectangle. So when you go to the second rectangle, the left endpoint is 6. You plug that into the function, and you get 3 times the square root of 6, and that's the height of the rectangle. And then, of course, times the width, which is 2. And we just continue to do this for each rectangle. Okay, so the area of the next rectangle, left endpoint is 8. Plug 8 in to the function. You get 3 times the square root of 8 for the height, times the width, which is 2, and that gives you the area of that rectangle. This one, the left endpoint is 10. You can see plugging 10 in, that gives you the height, 3 times the square root of 10 times the width, which is 2. So that's the area of that fourth rectangle. The fifth one, the left endpoint is 12. So that's the height, 3 times the square root of 12 times the width, which is 2, and that's the area of the fifth one. And then finally, the sixth rectangle, the left endpoint here is 14. And so you plug that into the function, you get 3 times the square root of 14, which is the height of this rectangle, and then times the width, which is 2. Okay, and so that's the area of that last rectangle. And when you add all those together, that gives you the left Riemann sum. Now remember, the left Riemann sum gives us an approximation for the area that's trapped underneath this curve, starting at x equals 4 and ending at x equals 16. So this is 105.876 is the approximate area trapped beneath this curve. Okay, so if you do a right Riemann sum with this, by the way, notice that this would be an underestimation because the areas here would be less than the actual area. Missing the little white area here. That's your error. Okay, so this would be an underestimation. Now let's do a right Riemann sum, again with 6 subintervals. Okay, so now our grid points are still 4, 6, 8, 10, 12, 14, 16. Delta x is still equal to 2. But now in this first subinterval that goes from 4 to 6, we're going to pick the right endpoint to determine the height. Okay, so this would be the height of the first rectangle, okay, which would be 3 times the square root of 6, and then times the width, which is 2, and that gives you the area of this rectangle. Okay, and then just continue to do this. Here's the second rectangle. The right endpoint is 8. You plug an 8 in here, you get the height, multiply that by the width, and that gives you the area of this rectangle. Here, the right endpoint would be 10. You plug 10 in, you get 3 times the square root of 10 for the height, and then times 2, which is the width, and that gives you the area of this one. This one, the right endpoint is 12. So the height is 3 times the square root of 12 times the width, which is 2. And that gives you the area of this rectangle. This one, you'd plug in the right endpoint again, which is 14. So the height is 3 times the square root of 14 times the width, which is 2. So that's the area of this fifth rectangle. And then the last one, the right endpoint is 16. So the height is 3 times the square root of 16, and then the width is 2. And so that gives you the area of the last rectangle here. Okay, and then you add up all those areas, and that gives you your right Riemann sum. Now notice in this case, the right Riemann sum is actually overestimating the actual area in here because we have too much area now, right? It's this little piece in here, and here, and here, and here, and here. So this is an overestimation of the actual area. So the left Riemann sum was an underestimation. The right Riemann sum is an overestimation. Now, that's not always the case. It depends on what your function looks like. In this particular case, one was underestimating it and the other was overestimating it. Okay, so then let's do a midpoint Riemann sum. By the way, before we go on to the midpoint Riemann sum, let me just mention that the left Riemann sum was 105.876 and the right Riemann sum was 117.876. And we know that this one underestimated it and this one overestimated the actual area. And so we know that the actual area is somewhere in between these two numbers. Okay, and we can narrow the gap here between these two by increasing the number of rectangles. So that's the way we improve our approximation. Okay, but let's do a midpoint Riemann sum for this same function. Okay, again, we're going to use 6 rectangles, so n is still equal to 6. And we're still going from 4 to 16. And so the width of each of our rectangles is still going to be equal to 2. So our grid points remain the same. So the grid points are 4, 6, 8, 10, 12, 14, and 16. Now in this first subinterval, we're going to pick the midpoint of that subinterval to determine the height of the rectangle. So the midpoint between 4 and 6 is equal to 5. And of course, to figure that out, you could just say 4 plus 6 divided by 2. That gives you 5. Okay, then we plug that into the function, and that gives us the height of the rectangle. 3 times the square root of 5 times the width, which is 2. And so that's the area of the first rectangle. And you just keep doing this for each rectangle. The midpoint here would be 6 plus 8 divided by 2, which is 7. By the way, once you find the midpoint for one of these, then you can just continually add 2 to that midpoint to get the next midpoint. So 5 plus 2 is 7, right? 7 plus 2 is 9, 11, 13, 15. Those are the midpoints. So that's another way to get the midpoints. Anyway, once you have this midpoint, you plug that into the function. That's the height times the width. The midpoint here is 9. Plug 9 into the function. 3 times the square root of 9, that gives you the height times the width, which is 2. So that's the area of the third one. The midpoint here is 11, so you plug 11 in. You get 3 times the square root of 11, which gives the height times the width, which is 2. This one, plug in 13, because that's the midpoint. That's the height times the width. And then the last one, the midpoint is 15, so that's the height times the width. Again, you add up the areas, all the 6 areas of the 6 rectangles, and you get 112.06. Okay, so in this case, the midpoint Riemann sum happens to land in between the left and the right Riemann sum, right, which was this and this number. That's not always the case. Again, it depends on how what your function looks like. This happens to be an increasing function, and so since it's an increasing function, the left Riemann sum will be the smallest. The next one will be the midpoint Riemann sum, and then the right Riemann sum will be the largest. But that's only because it's an increasing function. Okay, so that's how you calculate left, right, and midpoint Riemann sums. And again, if you want to increase the accuracy of your Riemann sum, you would increase the number of subintervals, which increases the number of rectangles and reduces the error in your estimation. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.